Hello everybody, this is Mr. McAllen and we're on day 5 of unit 6 of the flipped classroom. So we're going to be working on trig functions of any angle. So there are three types of problems we're going to work on. The first type we already know how to do, we did it in class, and if you want to just fast forward through this, but if you need this for review, I suggest that you try this one out. Terminal side of an angle passes through the point 6, -8. Find the six trig ratios. Six trig ratios are the sine ratio, the cosine ratio, tangent, cosecant, secant, and cotangent of theta. So I'm going to pause the video. I would like you to try it now, and when I come back from the pause, we'll have the answers displayed, and hopefully this will give you some confidence on this type of a problem. Okay, well, I drew out the angle. I drew out the triangle. Remember, this is theta. This is a reference angle. The reference angle always is in that bow tie position. We talked about that in class. And the trig ratios are, remember, sine of theta is equal to -8/10. And when you simplify this, you get -4/5. Cosine will be 6/10. Simplified will give you 3/5. Tangent ratio will be -8/6, opposite over adjacent, which is -4/3. And then the reciprocals of these will give you the cosecant, secant, and cotangent. So that's how you do that first type of problem that we worked on in class. And if you missed class, this is a second dose of it. So the objective for this video is, if you're given clues about the terminal side of an angle, find the six trig ratios. So in this question, I'm only asking for the sine, cosine, and tangent, but they tell you that the terminal side is this equation of a line. So what you want to do is you want to plot what this line would be. So basically, you wanted to solve for y. Y equals, when you solve for y, let me just start out. You have 2x minus 4y equals 0. You solve for y. Y equals 1/2 of x. So it always starts at the origin because there's no y-intercept, and the slope of this line is 1/2. So that means you rise up 1 for every 2 you run over. Rise up 1 for every 2 you run over. Rise up 1 for every 2 you run over. That will be a slope of 1/2. You draw the line, and now you can make any triangle you like to find the trig ratio. I'm going to make a triangle that has a base. The x value would be 6, +6. Oh wait, they said quadrant 3. If this were quadrant 1, this would be fine, but I'm going to extend this line down this way, and the angle is down in this quadrant. So this would be a little bit different because it would be heading to the left by 6 and down by 3, but it still uses that same line to get to this point, -6, -3. So depending on the quadrant they tell you, when you draw your line, you should make sure your line goes into that quadrant from the origin. So we're going to use Pythagorean Theorem to find the hypotenuse, just like we did before. So the hypotenuse, you would take -6, square it, plus -3, square it, set that equal to the radius or hypotenuse squared. In the book, they refer to that as the radius. We're going to say hypotenuse. Hypotenuse squared is equal to 36 plus 9. Hypotenuse squared is equal to 45. Hypotenuse will be the root of 45. You should simplify your radicals if possible. This becomes 3√5. That's your hypotenuse. And now let's write up our six trig ratios. I'm going to just make that work smaller so it's not in the way. And I'm going to write up my trig ratios. The sine of theta. Remember theta. I'll clear up this so we don't have to see it. So theta is this angle here, but the reference angle is that acute angle, that's a bow tie angle. So the sine of theta will be -3 over 3 root 5. And this simplifies to give you 1 over root 5. The cosine of theta is going to give you -6 over 3 root 5. And that's going to give you -2 over root 5. The tangent of theta is equal to -3 over -6, which will be 1/2. I should rationalize my fractions. And this one will be, sorry, this should be negative, and this would be negative. So this would be negative. And then this one here would be -2 root 5 over 5. Those would be my 3 trig ratios if they give me an equation of a line. So the steps: plot the line. All these lines we give you will pass through the origin. Make sure you're in the right quadrant. And then depending on where, you could pick any point along this line that would help you figure out the hypotenuse. I just happen to go out to a nice big triangle. But the bigger the triangle, the more reducing of your fractions you're going to have to do. So I'd like you to try those problems. And the next one is if they give you a different type of clue. They say in example 2, take a moment to read the problem. I'm going to pause the video. So read the problem over, and then we'll discuss how we solve it. Okay, so the problem says that we have the sine ratio is equal to 1 over 3, negative. It's in the third quadrant. Find the other 5 trig ratios. Okay, so I'm going to write over here sine of theta equals -1 over 3. The cosine of theta and the tangent of theta we need to find. I already know the cosecant of theta, so I'm not going to waste any time. I'll make sure I get that right. So now we want to plot this. So this is a clue. It says that we have an angle in the third quadrant where we have the opposite side is 1. That's negative. And we know the hypotenuse is 3. So I know this may not be to scale, and you should not assume that because I drew it on the grid that the x side here is equal to 3. The hypotenuse is 3. I've got to find this side using Pythagorean Theorem. So what we do is we draw a right triangle, just like drawn below. We put theta there. We know that's -1. This is 3. Using Pythagorean Theorem, this is my x side. You would say x squared plus -1 squared, which is the y side, equals the hypotenuse squared, which is 3 squared. You solve for x. So x is going to equal the square root of 8, which can be simplified to give you 2 root 2. So now that we know the x side is 2 root 2, you also know that that's negative because in this quadrant, the x side points to the left. So using that angle as a reference angle, the cosine has got to be -2 root 2 over 3, cannot be simplified, and the tangent ratio is -1 over 2 root 2, which is also negative. You want to, before you rationalize that denominator, you want to just do your, do your reciprocal relationships. So secant of theta is equal to -3 over 2 root 2, which should be rationalized, and cotangent of theta, which is the negative and the negative make a positive, so you have 2 root 2 over 1. So in simplifying this one or rationalizing this one, this will be 1 over 2 times 2, and the root 2 will be in the top. So we'll end up having root 2 over 4 for that one. And rationalizing this one, we have -3 root 2 over 4. Hopefully this video has helped you figure out another representation of how they're going to ask us to find trig ratios if they give us clues about the terminal side and about existing trig ratios. I hope this video helps, and I look forward to hearing your comments.